Hello, guys. Welcome to Cheenta School of Statistics and Data Science. We are a team of extremely passionate teachers, researchers, and statisticians from the top universities of India and USA. Our mission is to help you curve your career in statistics, data science, and machine learning. How do we do that? Number one, we help you build your foundations. We achieve that by making an optimized plan for your learning journey. Number two, we help you prepare and ace your entrance examinations in statistics and data science, like IIT JAM MS, ISI Stat, and CMI MSC Data Science. Number three, we give our absolute best to help you design your career by organizing workshops and certified data science courses. To book a trial class for your preparation courses of IIT MS, ISIM Stat, and CMI MS Data Science, check out the first link in the description below. If you're enjoying the video, show some love by liking the video and subscribing to the channel. We welcome you again to this passionate community of budding statisticians and data scientists. Let's enjoy the rest of the video. Stay tuned and stay blessed.
Okay, so you have a set here A whose coordinate is n, and you also have a set A whose coordinate is n. So there is a missing information in the question, but I just got it in m strictly greater than 2, or maybe equals to. So there is a function f that maps elements from A to elements of P. The question is find the number of one-on functions. From A to B. So anyone who can help me how to solve this? I'll be at this one. For example, A, so we're mapping elements from A to B. So the way you can solve this question is, so it's a 1-1 function. So one element should not be mapped to two others, and at the same time, one element can only map to one distinct element because it's a function, and at the same time, it has to be one. So because it's a 1-1 function, it will look something like, for example, this element gets mapped to this one, and this element gets mapped to this one. Because it's 1-1, it's necessary that because there are two elements, it will only get mapped to two elements. It cannot get mapped to one element or three elements. That's important. So before that, we need to find out how many such two elements sets are possible in this set D. Because it's possible that this one gets mapped to these two elements as well. Or it is also possible that these two elements get mapped to these two ones. So we need to first select what are the two elements to which A can get mapped to B. This can be done in MC n ways. So out of these M elements, you are selecting a set of n elements. This can be done in MC ways. Now, I'll draw this again here. Say you fix this n elements to the right hand side. You have these two elements and three elements, and say, for example, fix that this element gets mapped to this one and this element gets mapped to this one. So it's possible that, so we have selected these two elements as our map. It's also possible that we can have a different mapping. This one gets mapped to here, and this one also gets mapped to. So we have two mappings for these two selected elements of D. Now, how will we find these two elements? How will we find this number 2? So it's something like this element has two choices. It can either get mapped to this one or it can get mapped to this one. This element has two choices, and this element will only have one choice, because once the first element gets mapped to one of these two elements, then one of these two elements which got mapped to is blocked. You have no other choice. So you will have 2 minus 1 choices for this element. And the total number of choices you will have is 2 times 2 minus 1, which is nothing but 2 factorial. So just do an extension. If you have n elements here, so this cardinality is n. If you have m elements here, the cardinality is m. Then you will be able to select these n elements from these m elements in MC n ways. And once you have selected, each of these elements will have, the first element will have n ways, second one will have n minus 1 ways, and so on. So MC n times n factorial. So these are the total number of 1 functions. So if you want a visual representation of how to solve this, I'll just take an example. Say you have two elements here, you have three elements. So this is A1, this is A2, this is B1, this is B3, this is B2. So the first map is, so I select these two elements. So I select these two elements for my map. So the first map is A1 goes to B1 and A2 goes to B2. This is my first map. So if you see, this is the one, A1 goes to B1 and A2 goes to B2. And B3 is just there. It's not getting mapped in. We're not concerned about whether it's a number function. Just that we should have a one. Now the second case is possible. Sorry, the second case that is possible is A1 goes to B2 and A2 goes to B1. Well, this case is the case where I'm selecting B1 and B2 as the elements which will get mapped to. Okay. Now the second, so now this case is exhausted. The next case we will say is, now I'm considering B2 and B3 as the next two elements which I want A1 and A2 to be mapped to. B2 and B3 are missing. For this, we will have A1 goes to B2 and B2 goes to B3. And A1 goes to B3 and A2 goes to B2. And the third case is I'm selecting these two elements, B1 and B3. So if I say B1 and B3, the first map is A1 goes to B1, B2 goes to B2, and the second map is A1 goes to B3 and B goes to B1. So if you see, how many such cases are there? So there are three cases. This is one case, this is one case, and this is one case. How will you find this three? It's simple. From these three elements we have from here, I want to select in how many ways I want to find in how many ways I want to select two elements out of these three. So that's why 3C2 will be 3. So you have these three cases. Now for each case, I'll just simply say it's okay. So for each case, you'll have two cases. Why? Because for A1, it will have two choices. And once you put once you map A1 to something, you only have one choice for A2. So for A2, you will have only one choice. For A1, you have two choices. So in total, you will have 2 times 1, two choices. 2 times 1, so this is, can be written as 2 factorial. So the answer is, if you have seen the previous generalization, the answer is 3 times 2 factorial. This is just a special case for MCN times n factorial. Okay. Any doubts?